All right, we're back. This unit is all about arrays, and in our last video, we started writing ArrayHelper. Arrays themselves don't really have methods. They technically have some, but not really. So the idea behind ArrayHelper is that we would take some common array algorithms, things that you tend to do with arrays, and put them in one spot. A single class that you could basically transfer from project to project. You can copy these into other SRC folders and you would have access to them. That's part of the reason that we separated ArrayHelper from the driver. The driver is where our actual main method is at. If you look in ArrayHelper, there isn't a main method, but the driver is relying on ArrayHelper. We're calling methods such as display, fill, and contains. Those are the three methods that we wrote in our last video. Display is a way to quickly print off the contents of the array. Remember that one of our shortcomings is that if we tried to just print the array, here my array is called numbears, what I'm going to get is the memory reference, the hexadecimal location around the hash code. This does not give me the contents. That's not very useful. So display is a way of handling that. It is possible that we get an array with a length of 0, which this is taking care of. But for everything else, we should be able to loop through. We're printing everything but the last element inside of the loop. We're saving the last element because I am doing the comma and space inside the loop, and I don't want that after my last element. So we are doing it what I would call manually outside the loop. We also wrote fill, which goes through and replaces every element in nums with x. Quick way to fill your array. And then contains, which is going to give us a true or false value if the integer x can be found in the integer array nums. We're going to pick up there, writing more common array algorithms, starting with count. Write the method count that returns the number of times the specified int occurs in the specified integer array. If I look at this method header, which by the way, I would practice this, right? Like I would take a look at this, pause the video, see if you could translate this method signature into a method header. This particular method is called count. It is going to be in our ArrayHelper class. So now that we're working with multiple classes, this becomes a little bit more important. I'm not writing this in the driver. This is going in ArrayHelper. The method count takes in two parameters, an integer array and a single integer. It is going to return an integer, and the underline indicates it is static. Okay, so I'm in ArrayHelper. We're going to go public, static. Our return type was int. The name of the method is count. We're going to take in an integer array. You can call this nums, you can call it something else. And we're going to take in an integer x. I like using x when we're talking about a specific number, right? Other single letters include n. N would be like n. N would be like an amount, a number of times. I is typically an index. X is referring to a specific element, right? So I want to count how many times does x occur in nums. This is going to return the number of times x occurs in nums. First thing I'm going to do in this method is I'm going to create an integer to keep my count, and that's going to start at 0. What we're going to do is loop through nums, and with each iteration I'm going to ask, is the current element the one that I'm looking for? If it is, I'll increase my count. If it's not, I just don't do anything. Let's loop. I have plugged in a standard loop. I forgot all about the IntelliJ shortcut syntax. I just went man mode on it and wrote it out. So we're starting at index 0. We'll keep looping as long as I is less than nums.length. Notice it's not less than or equal to. That would cause an index out of bounds. We'll keep going as long as I is less than the length. Keep in mind that the last element is going to be one less than the length, so this is keeping us in bounds. With each iteration, I'm going to ask, is the current element? Right, the current element is coming from nums at index I. I want to know, is it equal to the one that I'm looking for. Okay, nums is an entire integer array. That's all of the numbers. I'm going to use the square bracket notation in order to get a specific element at the current index. Right? So while nums is an entire integer array, nums at I is just a single integer. I'm going to compare that single integer to another integer using the equals relational operator. If this is true, it means the current element is one that I'm looking for. So what I'm going to do is increase my count by 1. Right? I'm going to say that count is what it was plus 1 more. Right? This will add 1 to count and then save it back in. You should know by now that we could shorthand assignment operator that thing. Right? Count plus equals 1 is the same thing. Or, because we're only increasing by 1, count plus plus. Okay, I left off the braces here because this is a single statement. And we can technically get rid of these braces as well because the if statement is the only thing that's actually in the for loop. Right? The body of my for loop is one if statement. The body of this if statement is just simply count plus plus. So I'm going to get rid of all those braces. Let's take a look at the logic. We're going to loop through the entire array. With each iteration, I'm going to ask, is the current element equal to the one I'm looking for? If so, we increase count by 1. If this is false, we just skip over it. Don't do anything. We'll keep going until we have tested all of the elements. After the loop is over, that means I've gone through every element in the array. I'm going to return count. It should be accurate. Let's test this out. I'm going to flip over to my driver. I've got an array already. There we have a contains. Note that contains and count could, in theory, return basically similar information. We'll talk more about that in just a moment. I'm going to say ArrayHelper dot count. I'm putting this into a print because the method count returns a value. If I didn't print off the value that's returned, it would just sit there and we wouldn't see it. So I'm going to pass it an integer array. I tried to say nums. There is no nums in this context. We have numbears. Which, by the way, I should comment this guy out. So I want to count inside of numbears how many times we'll say 2 occurs. Right. I'm not modifying my contents anywhere. We create the array with the initializer list. We see what the contents is using display. We see what the contents is using display, which is why we see this twice. And they want to know, does it contain a -1? It does. How many times does 2 occur? Once. Okay, why don't we add in another 2? And we see we get 2 of those. What about if I was to try to count a number that's not there at all? What if I tried to count 7? Notice we get 0. A moment ago, I said that contains and count can return similar information. Contains is actually pretty basic, right? Because we only get a true or false value. You get more information out of count, but it can also mimic contains. I want to know, does it contain -1? Right up here, we're asking, does it contain -1? I'm going to count -1. True, -1 is there. If I get some number with count that is greater than 0, that means it's there as well. Does it contain 7? Does it, let's count 7. Does it contain 7? False. I get a 0 whenever I go to count it. So that's what I mean by count can give you similar information to contains. Count is arguably more versatile, right? Because you can get more than just a true or false value. You can get the exact number of times it occurs, but it will also tell you, in a way, a true or false value. Kind of interesting. Okay. Looking back at our slides, what do they want us to do next? And by they, I mean me, because I wrote these. Our next one is called sum. Write a method sum that returns the sum of all the numbers in the specified integer array. Notice that we're taking in just a single integer array as our parameters. The name of the method is sum. It's in ArrayHelper. It's static. It's going to return an integer. I'm going to flip over to ArrayHelper. And we're going to go public static. Our return type is int. The name of the method is sum. It takes in an integer array, and we can call that whatever we want. Whatever we want. Now, that's how you'll refer to the integer array. So I don't necessarily recommend that. I'll stick with nums. This is going to feel incredibly similar. I'm going to create an int. This is going to be my sum, my total. You can technically call it sum. I don't want it to get confused here. And by calling it sum and then nums, the rhyming there can be confusing. So let's maybe call this total. That's going to start at 0. So far, I haven't added anything up. I'm going to loop through the integer array. And I'll use my for I syntax this time. We're going to start I at 0. And we'll say as long as I is less than nums.length. With each iteration, there's no if statement check here. I don't really care what the value is. I'm going to take it and add it to my sum, or add it to my total. So total is going to be what it was plus the current element. Okay, current element. We're going into the integer array, which is called nums. We need to get the current element, right? If I just did this, that's a problem. I need to go get the current element using the square bracket notation. And there we have it. So with each iteration, no if statement check here because I don't care what the element is. I'm going to take it and add it to my total. I'm going to take it, add it to my total, and save that result back into total. This is the same thing as using the shorthand assignment operator plus equals. But notice that whenever it is nums, that is the entire array, right? Those are just like incompatible data types, right? I want a single integer, the entire list. That just doesn't work. I need the current element. This is ultimately one statement, so you can get rid of these braces. Feel free to leave them in, by the way, if you like braces. I'm going to return total. Let's try it out. Like these other methods, I'm going to do an S out because this particular method actually returns something. I did not do an S out here because the display method itself does the printing. I'm going to do ArrayHelper sum on numbers. Should be what? 33 and 8 minus 1, 33 and 7, 40. Boom. That looks good to me. Index of. Before I move on to index of, I'm going to talk about a different type of loop, I think. I'm going to talk about a for each loop. We know while loops, we know for loops. This is the third type of loop that you'll learn in this class. We won't learn anymore. But there is a third type of loop that I'm asking you to know. It should be evident by now that working with arrays requires frequent use of loops in order to traverse the array. Array traversal is so common that Java and almost every modern day programming language contains a shortcut loop developed to make interacting through a sequential list of elements easier. The for each loop, sometimes called an enhanced for loop, which I hate this. I hate this terminology because enhanced makes it sound like it's better, and it's not. It's just different. I'm not going to lie to you, students don't really like for each loops, especially considering how much they like for loops. So the idea that this thing is better is going to be it should be annoying to you as it is annoying to me. It's not better. It's different. Ultimately, one of the main benefits is you get very clean syntax. Let's take a look. It's designed to access each element of the array sequentially. So here's our syntax. We're going to have the word for. Okay, that's the same. we're going to have the array data type, a variable name colon, first time we've ever seen colon as part of our syntax, and then the array variable. What? That probably didn't make any sense to you. I don't blame you. I find the best way to learn it is by example. So we have nums, and we're using an initializer list in order to give the values 3, 1, 4. We are saying for each integer, which we will refer to as x, in nums, print x. Okay, so I find the syntax of the for each loop becomes a little bit more intuitive if the parts are translated into English. This for each loop essentially says for each integer, which we will refer to as x, in nums, do something. For each integer, which we will refer to as x, in, that's what this colon ultimately means, nums, do something. Do something being the body of the loop. Okay, so this is just replacing this standard loop, right? This syntax here is functionally equivalent to this syntax here. Notice that we did it here, we did it here, we did it here, we did it here. This one is technically a little bit different because we stopped one early, right? This is why the for each loop kind of exists. This action of going through the array from beginning to end is extremely common. We've done it in almost every one of our methods in order to perform these common array algorithms. So that's why it exists. If I take a double array, I'm going to show you the differences, right? So we saw an example with an integer array. What if it's a double array? How does it change? Okay, because this is a double array, the individual data types of the elements are doubles, right? I'm saying for each double, which I'll refer to as my value, in values. Values is ultimately the array that I'm looping through. The individual elements are doubles. That's what this means. Okay, here this is a variable that I'm making up on the spot. It's how I want to refer to the current element. Okay, the array data type determines the type of elements we'll be iterating over. In this case, the array holds doubles. So we'll iterate over double elements. The last slot in the for each loop header is the array we're traversing. In this case, that array is values. The variable name that you use to refer to each element is independent of the array. You come up with this. It's whatever you want to call it. The variable name that's decided in the header dictates how you refer to each element in the body of the loop. So whatever I call the variable here, right? This is a variable. This is variable declaration. I have a data type. I have a variable name. Whatever you decide to call it here, that's how you refer to the current element in the body of the loop. If we were to use this for each loop header to print the elements and values, our SOP would appear as follows. Right, we're doing a print line of my value. So I would like to overload the sum method that we just wrote. We're going to take in, oh, this is bugging me. This should be underlined. We're going to take in a double array and return a double. And I want to practice our for each loop inside of this method. Okay? Follow along with me. I'm going to go public static double. That's what the header says here. Right, write a method that calculates the sum of all the elements in the specified array using a for each loop. We are taking in a double array. We're returning a double. This is the sum. I want to return the total of all the doubles in this array. Well, that is going to ultimately be a double data type as a result. If I take all the doubles and add them together, I'm going to get a double. I'm calling it values here. We could call it nums if you want. Let's call it nums. Take a look. In my ArrayHelper class, I've got a sum method that takes in an integer array. In my ArrayHelper class, I have a sum method that takes in a double array. We are overloading the sum method. We are overloading the sum method. Why? I have methods in the same class. These are both in ArrayHelper. They both have the same name, but the parameters are different. Think for a moment. Where have you seen some overloaded methods? We first encountered these when we were looking at string. Substring is the very first overloaded method that we saw, right? There are two versions of substring. They're both in the string class. They have the same name, substring, but their parameters are different. One took in a single integer, one took in two. We learned index of. That was overloaded. There were two versions of index of. They were both in the string class. They were both called index of. One took in a character, one took in a string. The parameters were different. That's what we're doing here. We're overloading it. There are two versions of sum. If I call sum and pass it an integer array, we're calling this version. If I call sum and pass in a double array, we're calling this version. They are going to functionally do the same thing, right? They are going to return the sum of all the elements in nums. I'm going to copy and paste this comment because these do the exact same thing, right? I'm going to create a total here. I'm going to start it up as an integer, and we'll talk about why that is wrong. I am now going to loop through, and what I would like to do, what is new, is I would like to use a for each loop. I'm ultimately looping through nums. This is the only array in this scope. So I'm going to say for each. For each, well, this is a double array. The individual elements are doubles. For each double, which I will refer to as x in nums. You know what? Yeah, we'll come back to that. Do something. For each double, which we will refer to as x in nums, do something. What I want to do in each iteration is add x to my total. Total is going to be what it currently was plus x. Okay. Why is this mad at me? Required type int provided double. I made total an integer up here. Maybe I shouldn't have done that, because this ultimately needs to be a double, right? If I add up all the elements in this double array, the result is going to be a double. Notice this is happy, so there's no syntax errors here. The syntax error down here is because I haven't returned anything yet. But this is happy, and it looks very similar to what we did up here. Up here, what we did was total is equal to total plus nums at I, right? That is it expanded. So what I want you to extract from this, x in this context is just simply the current element, right? The header of this loop starts at the very beginning of the array, goes through the end. The header of this loop is saying we're going to start at the very beginning of the array and go to the very end, right? Line 63 and line 52 are functionally equivalent. We're just looping through the array. Line 53 and line 65 are also functionally equivalent. I'm adding the current element to my total. So what x is replacing is the current element. It's replacing nums at I. Okay. The reason why I hesitated here earlier is because this is an element, one thing I would recommend is potentially calling this E, being short for element. You could type that out if you wanted to. I'd be okay with that. Note that this is mad. That's because there's no such thing as E in this context. It's now element. It is ultimately up to you. What I do not recommend is calling this I. You can do that, I don't recommend it because this has kind of a connotation that indicates it is an index, and that's not what it is. It's the element, right? It's not the position in the array. It's the literal thing in the array, which is why I recommend E element, something like that. X makes some sense, but as you can imagine, using a for each loop when you're looking for something, right? In theory, count could be restructured to use a for each loop. And if I'm using X as the element that I'm searching for, I would not be able to use it in my header here. So that's why I would also recommend kind of staying away from X. X being a specific number, what you're looking for, E being the current element. Okay? We can shorthand assignment operator this. And I ultimately only have one statement, so I can get rid of the braces. And once I go through the entire double array, we should have an accurate total. So I'm going to return it. Okay. These are functionally equivalent. Now, I overloaded the method just to give us some more functionality, to kind of talk about overloaded methods, but they do the same thing. They just go through nums and add everything up. Here I'm doing it with a for loop. Here I'm doing it with a for each loop, and they are functionally equivalent. I'm going to flip over to the driver. I want to test the sum method that I just wrote. In order to do that, I'm going to need a double array. I'm going to call it values, and I'm going to fill it with doubles. Of note, we've seen it in other videos, but you can throw an integer in here. It's like saving an integer into a single double variable. You can do that. You can save an int into a double. Once it's in the double array, it'll be treated as a double. This will say 7.0, for instance, if I tried to print this. Now, I want to test the ArrayHelper sum method, and I'm going to pass in values. I'm not going to comment on this round off error that's happening here. What I will comment on, so this value, this 40, came from us calling sum. This value, the 61 point whatever, came from us calling sum. How does it know which version to use? Here, I passed in an integer array, so we called this version of sum. Here, I passed in a double array, so we called this version of sum. Notice that in the driver, you can't really tell the difference between it, right? It's just ArrayHelper sum, ArrayHelper sum. So when I say overloading methods gives you this seamless experience, it gives the user a seamless experience, right? You're not really, you're not trying hard to call a specific version. You're just saying ArrayHelper sum, and depending on what you give it, it works. But this is how overloading can work. They have the same name. They're both called sum. They're both in ArrayHelper, but the parameters are technically different. The compiler knows to call this version because we give it an integer array. The compiler knows to call this version because we gave it a double array. That's it. That is why the parameters need to be different. And that is why we say differing parameters. It's not a different number of parameters. Technically, these are both only taking in one parameter, an array. But the data types are different. Here it's an integer array. Here it's a double array. Okay. What this is supposed to be about is the for each loop. Right? This is just functionally the same thing as doing this. But notice how clean the syntax is. That's kind of the point. Looping through an array from beginning to end happens so frequently, they were like, let's clean it up. Let's do this. Okay. I am also going to fix it here. I would like this to be underlined, please, because it is static. So there is a solution. This could be a shorthand assignment operator. The for each loop merely simplifies the syntax that frequently occurs when using a for loop to traverse an array. So the following two loops are equivalent. On the left-hand side, given that we have integer array nums with a length of 10, I'm looping through and printing off the current element, which I'm just calling num, right? For each integer, which we'll call num in nums. The whole array is an integer array. The individual elements are integers. I'm just printing it off. Over here, I'm using a for loop to do the exact same thing. But, ooh, take a look. This is the most important slide, and you're going to struggle with this in this class. If you take AP Computer Science 8, you're going to struggle with it in that class as well. The first thing that happens here is that I'm saving the current element into a local variable. And then for the rest of the iteration, we're working with that variable. That is kind of happening behind the scenes. That's basically what you're doing here when you say int num. When you say int num, you're creating a variable and saving in the current variable, the current value, I should say, the current element. And then for the rest of the iteration, that is what num is. Okay. We'll come back to that because it's going to lead us into a discussion about the pros and cons of a for each loop. The for each loop has its own set of advantages and disadvantages. The simplified syntax should be an obvious advantage to you. But in addition, for each loops naturally avoid index out of bounds errors. Right? It is impossible to get an index out of bounds error. I don't want to say completely impossible. It is basically impossible to get an index out of bounds error because there's no index. Look at my syntax. E is an element. There's no index. How can I go out of bounds? How can I access an index that is out of bounds when there isn't an index? So we naturally avoid those things. There's no need to worry about I is less than the length versus I is less than array.length minus 1, which, by the way, there is arguably some debate here. We obviously use this. I've seen some people do this, and you could do this. It's nasty. So we just inherently just go from beginning to end. We don't ever have to worry about index out of bounds. However, keep in mind the for each loop has a very specific purpose. We're trying to access the elements in the array from beginning to end. The direction is set, so we can't go backwards, for instance. Right? With our traditional for loop, we could start at the last element, decrementing, which means that we're going to approach the beginning, the first element, which is 0. Notice that we're saying I is greater than or equal to 0. That equal is important because index 0 is a valid index, right? We do want to access that element. So this goes from end to beginning without any index out of bounds issues. You can't do that with a for each loop. The direction is set, right? Look at this header. This is it. I can't really modify a direction. So this would be an advantage that a for loop has. We can go from end to beginning, which you do sometimes. In addition, some common operations such as finding the index at which an element occurs cannot be performed using a for each loop. I hinted at an index of method before we got started on for each loops. We'll be coding that very soon. If there's no index, there's no index. There's no index. There is no index here. Okay, so a method that, like index of, which is going to work how you think it does, I wouldn't be able to do it. Lastly, and this is the thing that is just going to just drive you bananas. For each loops cannot be used to modify the contents of an array. That's a little loose of a statement. But let me show you. Let me show you. I'm going to flip over to my driver. I have a double array here ready to go. I could easily use numbers instead, but I'm going to use the double array. Let's loop through it. I'm going to create a for each loop that goes through values. I'm going to say for each double, which I will call E, in values. What the slides here are saying is that the for each loop can't be used to modify the contents of an array. Okay, how would I modify the contents? Well, I want the current element to become 18. I'm now going to, oh, this is why I should have done the integer array. Let's change this. Sorry, I was about to do ArrayHelper dot display values. That's a syntax error. Think for a moment. Why? Why is this an error? I'm trying to pass in values, which is a double array. My method takes in an integer array. So what we should do is probably overload this, but I want to get to the point. And instead, I'm going to loop through numbers. Each element in numbers is an integer. So let's do that. We'll loop through numbers. I'm going to try to change every element to 18, and then I'm going to display it. Let's maybe get rid of some of these other SOPs. So I'm going to leave this one so we can see the original value, the original values, the original integers that are in numbers. And then I'm going to loop through numbers and try to change everything to 18 and then print it off. That didn't work. Okay, well, if this was a for loop, think about how you would do it, right? We'll do the for I syntax. I'm going to loop through numbers dot length. And what I'm going to do, we basically have done this already, right? I'm going to say numbers at I is specifically an 18. Right, I'm going to comment out this for each loop. I've got numbers up here with these values. We're going to print it. So we'll see those values here in our console like we do now. I'm going to loop through using a for loop, changing the elements to 18 specifically. And then I'm going to print it off. So it works. I can change the things. The for each loop is basically doing the same thing, right? The for each loop is just saying we're going to take the current element, change it to 18. The for loop is saying we're going to take the current element, change it to 18. Yet when I do the for each loop, my numbers are still the same. Okay, let's talk about why. I'm going to go back to this one. What is happening behind the scenes is that we are creating a variable and saving in the current value. And then for the rest of the iteration, we're working with that variable. These two, right, the left side, the right side are functionally equivalent. This thing seems a little bit odd, but that is what your for each loop is doing. Okay, so I'll express it using the for loop first. The first thing that our for each loop is actually doing is creating integer e and saving in numbers at I. We are then saying e is equal to 18. I'm going to run this. All right, we have numbers. We'll see the original values. I'm going to loop through using a for loop. We'll change everything to 18 in theory, and then print off numbers. It didn't change because I didn't change numbers. I'm not changing the array here. What I'm changing is e. E is just some stupid variable that it gets created and destroyed with each iteration. E is changing. I can prove that E is changing because I can print it off. So I am, in fact, changing E. What I'm not changing is the array. Simply put, if you want to change the array, you got to refer to it, right? I'm changing E. What I'm not changing is the array. If I want to change the array, I got to refer to it. This will change it. I'm referring to the array where I'm changing it. Okay. So, I say all this to say that this is what's happening in the for each loop, right? This loop and this loop are now functionally equivalent. They are the exact same thing. They are doing the exact same. What I am doing behind the scenes is creating a variable and saving it in, saving in the current element. Then for the rest of the iteration, we're working with that variable. So whenever I say e equals 18, I am changing e. Right? I'm going to print off e here. I'm going to comment out my for loop. We will see numbers in its original state. I go through, I change e to 18, but what I'm not changing is numbers. Notice that I'm not referring to the array. This is what's going to drive people crazy. And this is what the slides are saying. Whenever they say, for each loops cannot be used to modify the contents of an array. That's a little bit loose. Technically you can with some really janky looking code. But if you want to change the array, you got to refer to it. And if you're going to use that square bracket notation, you need an index. If you need an index, a for each loop is not what you want. You want the traditional for loop. Okay, so with that in mind, we're going to pause there, and I'll see you in the next one.